Let us do one more problem based on the momentum. Okay, momentum impulse. A 150-gram baseball is thrown with a speed of 20 meters per second. It is hit straight back toward the pitcher at a speed of 40 meters per second. The impulsive force of the bat on the ball has the shape shown in figure. What is the maximum force that the bat exerts on the ball? What is the average force that the bat exerts on the ball? You have to find out two things. One is the maximum force, another one is average force. Now let us try to do this problem. Here, the ball is thrown at the bat, okay, and then the ball mass is given as 150 grams, and then it is traveling with a speed of 20 meters per second. Okay, and then it is going towards the left. That is why I take this as negative. And then after hitting the bat hits the ball hits the bat, and then on return journey, I will take this as the plus 40 meters per second. Okay, this is the information, and additional information is given in the graph. Okay, now what I do is I will do using the momentum impulse theorem. You may be knowing the momentum impulse theorem, otherwise I will do it. Okay, momentum impulse theorem. What is the momentum impulse theorem? You know from the Newton's second law, F is equal to ma. Okay, and then A is equal to Vf minus Vi over T. Am I right? Now I will substitute A here. Therefore, F is equal to m Vf minus Vi over T. Or I will write Ft is equal to mvf minus mvi. Okay, you know P is equal to mv. Therefore, Pf is equal to mvf, and then Pi is equal to mvi. Okay, therefore, here this is Ft is equal to Pf minus Pi. Therefore, Ft is equal to, Ft is nothing but your impulse J. Therefore, J is equal to delta P. Here, Ft is equal to J. J is nothing but your impulse. And then delta P is your change in momentum. Okay, so from the graph, Ft, how we get the Ft? Ft we can find out as the area under the curve. Okay, so from graph, impulse J is equal to area under curve. But here, they haven't given the force. Only time is given to us. So what we do is, J is equal to area under the curve means half base into height. Okay. Therefore, here, half base is nothing but 0.60 milliseconds. Milliseconds means 10 to the power of minus 3 seconds. And then height is given as Fmax. Okay, up to this, we know something about the impulse. Okay, now using the data, we will find out the change in momentum. Okay, so Pi is equal to, this is MBI, that is equal to 150 grams. No, so 150 grams means 150 divided by 1000. Okay, into Vi is minus 20. Okay, and then this, what happens this one, or else I will write it later. Pf is equal to mvf is equal to 150 divided by 1000 into 40. Okay, therefore delta P is equal to Pf minus Pi is equal to 0.150 times 40 minus of 20. Okay, so this is equal to 0.150 into, this is 60. So this gives 9 kilogram meter per second. Am I right? Now he is asking us to find out the F average. F average is equal to delta P divided by delta T. Okay, so this is delta P is equal to 9 kilogram meter per second divided by, we have 6.6 milliseconds, 0.6 into 10 to the power of minus 3 seconds. This gives, we have how much? This is 6 now. This is 3 by 2, so 15,000 newtons. Okay, now we have to find out F maximum. So to find out the F max, I will write this one. This is 0.3 into 10 to the power of minus 3. F max into 0.3 into 10 to the power of minus 3 is equal to, because this is J, am I right? J is equal to delta P. So delta P we already found out, 9 is equal to 9 kilogram meter per second. Therefore, F max is equal to 9 kilogram meter per second divided by 0.3 into 10 to the power of minus 3. Therefore, F max is equal to 30,000 newtons. This is the answer. Okay. Thank you. Bye-bye.